Okay. Last time we studied breakaway points and how we calculate them. Uh, we learned that breakaway points happen because uh, there are two poles or two loci, separate loci that meet each other, and they need to leave the real axis. So that's the reason why they happen, and we studied how to compute them, how to calculate them. Okay, now the question is, uh, or the important notice is that after we calculate the breakaway points, we need to check them. We need to check if uh, the result we have got is correct, if it makes sense, if it's valid. If it's not, we exclude those results, those findings from the answer. We saw an example. We saw this example. So you never start with finding breakaway points. We always follow the steps of the table. What are the steps of the table? You first make sure that you have written the uh, the open loop poles and zeros uh, in the standard form. So you write the transfer function in the standard form. Then you find the zeros and poles of the open loop system. You plot them. Try to make sure, try to think about it. How many separate loci do I have? What's the direction that each loci is taking? And then the angle and the position of asymptotes. Do I need to find whether or not the the loci cross the imaginary axis, and then whether or not the loci meet each other, and therefore um, I need to find breakaway points. So for this example, uh, the location of poles and zeros are the origin twice and -2. These are the poles, and the 0 is -4. Why am I just simply calculating these? Because h is 1, so g times h is just g. So I can, and it's written already in the standard format. So I can just focus on the poles and zeros of g and call them poles and zeros of the loop transfer function. So g would be the loop transfer function in this example. Then I found the location and the angle of asymptotes. So the location would be at 1, and the angle would be 90 degrees and 270 degrees. And then I plot poles and zeros of the loop transfer function. I use the rule that tells me what part of the real axis is in the locus. So I realize that -2 to -4 is in the locus. And then I put the direction, the arrow on the loci, and then I realized that okay, I don't need anything here. Now, because I have two poles at the origin, it is clear that the breakaway point is at the origin, but I can still calculate it. Now we want to see this example. Okay, so in this example again, h is 1. And I have g written in this way, equation 10. Um, Again, g times h is in standard format, so the poles and zeros of the loop transfer function are just poles and zeros of g. So if I try to find the poles and zeros of g, I see that there's 1 0 at -2, and there are two poles at -1 plus minus j square root of 2. The number of poles is more than the number of zeros, therefore the number of separate loci are the number of poles, which is, in this case, is 2. So I'm going to have two separate loci. Now, if I try to plot zeros and poles of the loop transfer function, so this is the finished work, but just for a second, consider we don't have these two these colors and anything on the map. So I place poles and zeros here, and then I determine where on the real axis is in the locus. So on the right hand side of -2, either I have nothing up to this point, or between -2 and this point, which is -1, I have two poles, which, so here I have zero things on my right hand side. Here I have two things on my right hand side, which doesn't really make it any difference because even numbers are not important. Now, on the left-hand side of -2 is in the locus, because if I'm standing on the left-hand side of -2, I have three things, poles or zeros on the right-hand side. So from -2 to -infinity is in the locus. Now, when I want to put the arrows on the axis, I don't know what to do in this case. But it's clear that I have two poles that I don't know what happened to them. So there are just two poles, and I don't know how they are going to end up reaching to -2. So they probably meet somewhere, meet each other at some place. So it makes sense to compute the breakaway points. Um, so how do I compute the breakaway points? I find k, which is the inverse of my gh, and then I take the derivative with respect to s, and I put that equal to 0. Then I try to solve this equation. So how would this equation be equal to 0 when the numerator is 0? If I solve that, I get s equals to -3.57 and s is equal to -0.36. Now I need to actually check these results and see if it makes sense. So -0.30 is here. Does it make sense? I already know that -0.30, which is here, is not in the locus. How would these two poles meet each other there? It doesn't make sense. But -3.57 makes sense. So at -3.57, these two poles meet each other, and then one of them goes to -infinity, one of them goes to the 0. So do we need any asymptotes? No, but you can compute it. It's going to give you one number. It's going to just give you 180 degrees, which is correct. One of the loci is going to negative or positive or negative 180 degrees. So is there anything else we need to compute here? Well, we don't need to find where they cross the j omega axis. We already noticed that one of the loci goes to -infinity. But I wish there was a way that I could predict how this circle happens. Like, how do I know that this line comes out of my pole this way? Why not like this? Why not like this? So maybe I wish I had a way to calculate the angle that I'm leaving this pole, or the angle that I enter a 0. And that's the next topic we want to talk about, determine the angle of locus departure. So to find the angle of locus departure from complex poles, we need to use this equation. So this equation is explaining this. You want to find the angle of departure from a complex pole. You write 180 degrees times 2k plus 1. Then you subtract the summation of the angle that that pole makes with other poles, and then you add to it the summation of the angle that that specific pole makes to all zeros. Okay, this is a little complicated to understand, so I explain it again. I go to the previous picture. I want to find the angle of departure from the pole at -1 plus j square root of 2. Obviously, the angle of departure from this pole is different than the angle of departure from this pole. If I have any other poles, the angle of departure from them is different. So for angle of departure from a pole, it makes sense to compute the angle of departure from that specific pole. You can uh, you can compute it as many times as you have poles. So how do I compute the angle of departure from this pole? I need to write theta is equal to 180 degrees 2k times 2k plus 1. Then I want to find the summation of the angle of this pole with other poles. So what's the angle that this pole makes with other poles? Well, I have only one other pole, and it's this pole. So how would I find the angle that this pole makes with this pole? If I connect them, they make an angle that looks like this. So it's 90 degrees. How would I find the angle that this pole makes to the 0? This is my 0. So the angle that the pole makes with the 0 is this. How would I compute this angle? From geometry, how would you do that? What information do I have and what do I want? I want the angle here, this angle, and the information I have is I know the location of this pole, I know the location of the 0. So I can find their distance, I can find horizontally and vertically how far they are, and then I can find this angle from the definition of tangent of the angle. So let's see this example. I want to find alpha and I want to find beta. How do I find alpha? Well, alpha, if alpha is the angle I want to find, the tangent of this angle would be this, which is square root of 2, divide by this edge. What's this edge? -2 and -1. So the length of this edge of this triangle is 1. So I divide square root of 2 by 1. And that would be the tangent of this angle. So to find the angle, I take inverse of tangent or arctangent. So I take arctangent of square root of 2 divided by 2 minus 1, which is 54 degrees. I do the same thing. I can do the same thing for this angle, but it's pretty clear it's 90 degrees. So 180 degrees minus 90 plus 54.73 is 144 degrees. So that would be the angle of departure from this pole. So this angle is 144 degrees. It's more than 90 degrees and it's less than 180 degrees, right? So it makes sense. I have 144 degrees. So this is explaining that again in symbolic terms, that alpha would be arctangent of P divided by C.